Hello everyone, my name is Sean Name, and today I'll be doing Fluids Project 3, the 2D wind tunnel simulation, and I'll be doing it for the 20 hertz portion. So first things first, fluid flow fluent, let's create a standalone system, click on our geometry and make sure it is in 2D, and then right-click geometry and we're going to have a new design modular geometry. Now once we get in here, we'll start making our wind tunnel and our test section and traction chamber and everything. So we're going to select the XY plane to make sure our units are in inches, XY plane, sketching, and let's start with our line. So just draw a nice line. Let's make sure that this line is 22 inches. So let's go dimensions, vertical, here to the top of our line, which I don't know where I put. Yep. Let's make sure this is 22 inches. Please select it. 22 inches. Zoom out a little bit, and then it's clear it's not centered. So this is a very important part. Let's add our constraints. Midpoint. Select a midpoint around the origin, and boom, that's gonna make it so that we have 11 on this top tab, and 11 on the top, 11 on the bottom, and then we can start creating our wind tunnels. Let's go draw line, and then this will be a 15-inch settling chamber, and then we just start drawing our just a general shape. We finish with our diffuser of our wind tunnel. So to finish with the diffuser here. Awesome. And then now we can start dimensioning everything. So let's go a horizontal dimension for here. Boom, boom. And then this horizontal dimension, H2, should be 15 inches. And we should have a length slash distance here, from here to here. L3 is going to be 24 inches. And then let's have another horizontal, our testing section, TS. And TS is going to be 12 inches. Then let's go down, length slash distance here to here. And this one's going to be L5 will be 42 inches for our settling chamber. Awesome. And now let's have an angle. So we're getting the angle between our test section and our settling chamber. And this should come out to be 177 degrees. Actually, sorry, 183. It was at 3 degrees downwards. And then let's have a vertical distance here between here and here of 3 inches. V2. Where are you? Did I select that as a length? Yeah, let's not have that as a length. I want that as a vertical between here and the midpoint. There we go. Now that should say every 8, 3 inches, and that's awesome. So everything here is defined. And then the next step is that we want to kind of mirror this up here. So we have this top half of our test section. So that's awesome. So let's just select you, you. Come on. Here. All right, control click. Come on. One. Oh, I think it's because I still have it. Yeah, I still have V8 selected. 1, 2, 3, 4. And we're gonna do let's see, where was it? Modify, replicate. Replicate it. 8 degrees. Oh, and none of it's selected again. Awesome. And then enter. Oh, and then we have to indicate our handle, which is going to be on our origin. And I just want, this is always the toughest part for me. I don't know why. I just struggle to select our origin. No, no, Mia, please. That's not, I don't want it. So yeah, let me exit out of this because this is being weird. So let me just select all this, I'm sorry. And then we're gonna click replicate, 100 degrees, about here, awesome. And then we right click and flip vertical and then kind of attach it there and you click escape. And now we have our test section, but not quite done yet since we do need to do a couple more dimensions. So let's do our length slash C. Whatever's not blue, basically, we're just gonna redimension here. So this should be L9, 24 inches, and horizontal. And that H10 should be 12 inches. And then another length slash distance here to here. That should be let's see, 42 inches. And then we need another angle between you and you. Make sure that is correct. That was already correct at 183. Then we need a vertical between here and here to be 3 inches. Awesome. And then let's draw a line between these two. And awesome. Now everything is fully defined. Everything's blue. Everyone's happy. So we're going to go to tools. Sorry, concept, surface from sketches. Select sketch 1. Click apply. We're going to click on sketch 1. See concept. And then generate. Awesome. So now we should have sketch 1 as our part 1 body. And that looks all good. So now we're ready to move on to our mesh. So let's exit out of this and make sure just for good keeping, click update. And then let's double click our mesh and let that open up. And now that our mesh is loading up, just give it a second. You're going to click on our mesh, right click, insert method. And then we're just gonna make sure we could choose our face here and click generate. Oh, sorry. Let's delete that. And then here, apply, and we want triangles. And here you click generate. Now we have this mesh as you just saw. And I just went away. Yep, and then we are going to go into our mesh, our element size instead of the default. Do 0.01. And that looks awesome. Click update. Yep, and this mesh looks very nice. And then now we want to define our wall. So let's control click all our edges. And then this one we called wind underscore tunnel underscore wall. Let me click OK. Awesome. For this one, click N, wind tunnel inlet, and wind tunnel outlet. And then name sections, boom, boom, boom. And then we're done with our meshing. Let's just make sure we go in here, click update, let that update. And then you should get a nice green check mark. Let's click on setup, double click. Then you should have a window pop up. Let me drag it over. We have double precision and then solver processes. It's called 2. And click start. And that's going to take a little second to load. Okay, and now once we are in here, we have our nice model. We're gonna click plus on the models, double click energy, and it's just energy equation must be turned on. Awesome. And viscous, we're gonna change it from K omega to K epsilon. And then we want to turn on, where is it? We have K epsilon. Then when is our enhanced wall treatment? And then we also want to turn on pressure and thermal effects and click OK. So that's updated correctly. Then we want to set our boundary conditions. Double click. So wind tunnel inlet. And let this load for a second. So let me see, where's this window? Should be popping up any moment now. There we go. And for 20 hertz, there's a calculation behind this, but for simplicity, 1256236 meters per second is 20 hertz. So apply, close, and then we're going to go down to initialization, double click. And it's a hybrid initialization, click initialize, and everything's good. Don't worry about this. Run calculation, number of iterations to 150. Oh, that's 150, and then calculate. So now a bunch of iterations are going to come up here, and just making sure that everything is converging correctly. So just let this go. This all looks good to me. It's not what we're aiming for as a result there, but now our calculation is complete. Let's do our contours. So to do contours, let's go graphics, double click on contours, and then select all of these. Boom, 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 boom. And then, so we want our 4 contours of static pressures. Let's save and display. Then here's your static pressure. And then we want our dynamic pressure. So save and display. Here's our dynamic pressure. And we want our total pressure, not relative total pressure, total pressure. Then here's our total pressure. And then let's click on velocity, velocity magnitude, save and display. And then in order to save any of these, so you do the same thing, but you have to click, what does it say? Make sure you click off. Oh, yeah, no, this is not, you don't write any of these files. We need to get our graphs now. So let's go to plots, XY plot. Let this come up. And now it's going to ask us where to plot it. And in order to do that, we're going to click on new surface by line / rake. And then this is going to ask us for, since we plotted it the way we did, it's going to ask us for a distance from here to here. And so we can find that from our sketch. I'm just going to tell you guys that that distance is 2.3259. Awesome. And then you click create and close. And that is our center line. And then you could do a save / plot for your static pressure, save / plot for your dynamic pressure, save / plot for your total pressure, and last but not least for your velocity. Save / plot. In order to save all these, you're just going to check write to file for each one. You click write, and then you save it in your desired location. And then this is all you need to do for the setup part. So once you save it, you'll open it and it'll look something like this. So you have your dynamic pressure, your static pressure, your total pressure. This is all just the exported data, this raw data that ANSYS will give you. And it's all located right here. And then once you put it in, once you put it into Excel, this is what it's going to look like. So right here, we have our dynamic pressure, our static pressure, our total pressure, and our velocity. And you just plot them, you create tables, and here are your graphs. You position on the bottom, and that is how you do project 2 for fluid mechanics. Thank you for watching.